Hello, everyone. It's so good to be back here again. Welcome to this series of teachings that we're pushing out in computer science. Like I said earlier in our earlier video, we sent out a video on compiler construction. This video could pass for anyone, undergraduate students, postgraduate students, lovers of computer science, people that want to learn computing concepts, people in information science, engineering, related science courses. It could just pass for anyone. So please feel free to, subscribe, please, share, like, and let's get started. It's at ETENG. I lecture computer science in the university. I work in Calabar. Now, in this series, is going to be database design and management. And I like to use this opportunity to acknowledge the authors of database system concepts, Abraham, and others. I want to thank you so much because most of the concepts that I'm sharing here actually came from that book. Thank you, and God bless you. So in this lecture, we'll quickly look at, the reason for database management systems. We'll look at views of data models, just introductory parts, data definition language, data manipulation language, transaction management, storage management, database administration, who database users are, and the overall system structure of databases. So, what are databases? We all use databases. I mean, directly or indirectly, whether we know it or not. If using your email application, you're receiving your messages on your inbox, you have messages in your spam, you're sent messages, you're actually interfacing with the database, whether you know it or not. All right. If you're trying to enroll in a university somewhere and you're filling in a form, they're receiving your data, you're also interfacing with a database, somewhere. So databases are actually everywhere. And what are they? They are simply collection of interrelated data. That's what they are. So it has to be data concerning a particular, domain. Could be data, on banking, university data. You want to look at sales. You talk about customers. Technically, data on anything. Data on illnesses, medical data, whatever it is. But these data have to be, related. There has to be interaction between the entities involved in this data. And also, of course, it must be persistent. It must be stored in some secondary storage device so that it can, of course, be used again. Okay, and then we always have a set of programs that help you to access this data. And we have, them as database management systems. So database management systems actually, provide you the convenience and the ease of, creating, new databases, all right, manipulating existing databases and controlling these databases too. So they come in handy, they come in several flavors, they come in several forms. Are you using MySQL? Are you using Oracle? Are you using, whatever it is, what database management system in as easy as Microsoft Access. These are all database management systems, and they allow you to be able to work with your databases, like I earlier said. So why database management systems? To appreciate, why we use database management systems now, you would know that we actually came from a history of using file systems, and file systems were flawed with so many errors. First of all, there was a lot of, replication of data. Let me give you a practical instance. You enroll as an undergraduate student into a university, and, you come to the registry, information is gotten from you, your name, your age, and all of that. Before you even enrolled, as a student of the university, your information got to us when you're trying to write the exams and all of that. You go to the department, they get your information too. You go to the faculty, it's the same thing. If you have to go to, the medical clinic, some information is going to be gotten from you. So you realize that your information is in several places. If you're a female student and while you came in, you were single, and then in 200 level, you become married, of course, your marital status is going to change from single to married. Well, you can quickly change that in the department. Your lecturers were invited, they know all of that. But at the medical center, maybe you've not changed. So you find out that if you're not storing all of this using a database management system, having a database, all of these things are going to be stored, in different places, and you might have inconsistent records, like I just mentioned. In the department, you're married, but at medical center, you're still single. So there's also a problem of replicated data, a lot of data redundancy, because there's a lot of data, similar data everywhere. Okay, so the file systems came with much more problems than this. We had integrity problems, with the file system. And then security was also a problem. Now with modern database management systems, the database administrator can actually grant different levels of access. So a lecturer has more access to examination data than a student would have. And that's some form of security. But with the old file systems, we did not have all of that. Okay, there's also issue of concurrency problems. Let's assume that you want to withdraw money from an account and someone wants to pay money into that account at the same time. With database management systems, we can actually handle those concurrent accesses. So we find out that database management systems have come to solve a lot of problems that we inherited from the file systems and much more. Let's look at levels of abstraction of data. I'll start with this slide and then I'll come back to this one. So when you're viewing data, you could actually view data at several levels. You could view data from the physical level. At the physical level, you're actually talking about data that is stored to physical devices, stored on disk. How are you storing this data? As heap files, unsorted heap files, indexes, and all of that. You're detailed about how this data is being stored, okay? But at the logical level and at the conceptual level, you're just looking at, the entities that make up this data, this database you're using. Okay, for a university database, you're going to have entities like students, entities like a course, and they're bound to relate with each other. So a student would offer courses, so that's at the conceptual level. At the logical level, you're trying to create this data. You're trying to use the database management system that you've adopted, for this data to be able to actually create this data physically on your systems. And then at the view level, everybody is viewing the database from different angles. A lecturer is viewing the database differently from a student who just wants to register his course. So that's, talking about viewing data and the architecture of a database system. Okay, so we said that, at the logical level, like I said, what we actually inherited from older programming languages like Pascal and all of that, we're creating records, where a record is actually a collection of several fields, several attributes, okay? So we see a student's record, you have to know the student's matriculation number, the student's surname, the student's first name, his initials, his department, and all of that, okay? So that's, talking about the fact that data can be seen at different levels of abstraction, okay? Now, you also have to note that, you could see instances of data and you could also look at schemas. A schema is simply a logical structure of a database, okay? So at the schema level, it's like signature of what's in the database. You want to know the structure of this database. Okay, this database would contain matric number, like we said, would contain name, would contain this. At this point, there are no details, of what you have in the database, just the structure. But when you're talking about an instance of the database, it's like a snapshot, the states of the database as a specific point in time. So we talked about that student who, was single and is now married. So if you take a snapshot of the database at that point, you see that marital status is now, married for this student. So an instance of the database gives you the details of that database at a particular point in time, showing the state of that database. Beautiful. Now, for you to be able to, of course, work with, databases, you have to talk about data models. Data models actually are tools that help to describe several aspects of data. First of all, you describe the data. You describe, the relationships between this data. You describe the semantics, the meaning of this data. And then what constraints fall on this data? Is this a primary field? That means that, everyone on this database must have a unique, item in this particular field, like a matriculation number. No two students should have the same matriculation number. So, all of this information, can be described using what? A data model. And we have several types of data models, from entity relationship diagrams, which we are going to look at very quickly, to relational models, to object-oriented models, to semi-structured data models, and the older models that have been deprecated, nobody's really using them anymore, network models and hierarchical models. So there are different ways that data are structured, and the way that this data are structured determine how easy it is to carry out operations on this data. For instance, on a relational model that we're going to look at, it's very easy to just delete a row or insert a row. Okay. Now, so we're seeing the entity relationship model. And while we're trying to use a cross-foot model here, there are several ways that you could actually represent your entities, okay, and the relationship between them. So entities are like, objects that can stand alone, in your database. Like, you can't talk about a university database or a course registration, system and not mention students. So students are entity, of course. Once you can get some attributes, more than one, to describe a valid student, it can stand as an entity. And then, of course, the course could also stand as an entity. So we see these rectangular boxes representing what? The entities. On top, you have the name of that entity. And then inside that, you see what? The attributes of this entity. What are the things that distinguish a student? His matric number, his surname, like we've said already. What are the things that distinguish a course title, a course code, course unit, what credit unit is this course? And then we see the relationship between the student and the course. The student, of course, offers a course. So you can have one student offering many courses and a course being offered by many students, and that gives you a many-to-many cardinality. We'll talk about this in subsequent lectures. Okay, so beautiful. Now, looking at a relational model, like I said, it actually uses the concept of relations. And when you're talking about relations, you're talking about tables. Tables are made up of rows and columns. We call them tuples and fields, or tuples and attributes. Okay, so you have the row. So we have a row for a student whose surname is Akpan, and this student happens to be in computer science department. And it's very easy for you to go through, one student after the other. So a relational model is simple. You see the attributes, every model must have a title. This is a student table, and then it must have a heading. We see the several, options in this heading, matric number, and then we see the content or the body of this table. This particular table has about 5 records, 5 rows, 5 tuples. So that's, how easy a relational model is. And several database management systems like your Microsoft Access, like your MySQL, SQL actually, use the relational model. Now, for you to be able to use all of this data that you've put together, you have what we call a data definition language. A data definition language simply just allows you to create the object you need, allows you to create a table, allows you to create, your schemas, allows you to create your databases, because you can't even create a table if you don't have a database that is going to contain that table. And, the very simple syntax, normal things we know: create table, you give the name of that, database that you want to create. You want to create a student relation. Okay, sorry, not database, a student relation, a student table. Okay, and this student table, you want to identify some of the attributes, and you're trying to define their data types. Say, well, this is going to be character, variable character. I want to use that in storing, the matric number. Of course, you know that, in computing, when we define what the data type is, it explains many things. It explains how much space is going to be allocated in the computer for that, and it explains the kind of operation that are valid on that data type. For instance, you don't want to be dividing a name with another name. A division is not a valid operation when you're dealing with a string data type. So, that's as easy as it is. For data manipulation, once you've created your content, you've created your object, you want to be able to manipulate them. You want to be able to, for instance, update your records. You want to be able, for instance, to delete the records that you've created. For instance, God forbid a student dies and is not your student anymore, or leaves the university. I mean, that's a better example. Leaves the university, is not in the university anymore. You don't want to have, records of that student for a particular course that you're reporting for that semester. Maybe in your archives, of course, to show that that student was once in that school, it could still be there. So you have facilities in database management systems that allow you to do these simple manipulations on your data objects that you have created. All right. Like I said, who are the users of databases? Everyone uses databases. In fact, we all use databases, application programmers, sophisticated users, users that actually use specialized tools, to use the database. So see a structure at the end. Naive users are people that, they just interact with forms. I want to fill a form and that's all they can do, with the database. So people that actually have to use prepared templates to access the database and don't even know, that they are actually interfacing or interacting with the database at the back. So the database administrator is key in any database setting because he does a lot. He creates the schema, he defines the structure of what the database is going to look like. Nobody goes about to build a house without knowing what it will look like. So the first thing when you want to, start dealing with databases is not just to sit on the laptop and begin to type. It is for you to have a structure. What is my entire database going to look like? What are the objects in this database? Am I going to have forms? Am I going to have reports? Am I going to have tables? How are these tables going to be laid out? What's going to be the relationship between these tables? So all of those details, are things that are carried out by the database administrator. He deals with the schemas. He grants access. Like I said, a lecturer, of course, will have more access to an examination portal or database than a student. So those are the jobs of the database administrator. Now, several other aspects of databases that you need to know, when these databases have been created, transactions have to be carried out on them. And transactions are simply a collection of, several operations that must perform one logical function. So for instance, you actually want to withdraw money, from your bank account. There are several things. You have to key in your PIN and all of that. The system has to check whether you have enough money to even withdraw from and all that. So all of that have to be carried out as one functional unit. And for us, is either everything goes through, we say it commits, or if it doesn't go through, then it rolls back. It takes back, your database to the state that it was prior to you attempting this transaction. That's why sometimes you see that your account has been debited, but if something went wrong, it is reversed. So that's a transaction. So those are transactions. And of course, you must have, facilities in a database management system that would help you to manage transactions. And what if you have someone that wants to pay money into your account while you want to, withdraw from that account at the same time? So there's concurrency there, concurrent access. So something or someone has to manage this, and that's the concurrency control manager. The same goes for storage. You want to be able to store different levels of data in your database, and that also has to be handled. So all of that, are parts of what a database management system is. This is the overall system structure of what a database management system looks like. We see different levels of users of the system, the naive users, the sophisticated users, and database administrator. And all of them actually use different kinds of tools. Like I said, a sophisticated user would use query tools. So you just type your SQL codes at the back end, you know what to do, you run your scripts and all of that. But a naive user is just going to fill out forms. So different users actually use different tools depending on their level of expertise. And of course, all of this, input into this database have to be processed. So you have your database management language query. That part handles the queries. Queries have to be parsed, queries have to be optimized, things that we're going to look at in subsequent, teachings. And then, of course, it goes all the way down, like I mentioned, the architecture, down to the storage. You're storing different things, data dictionary, your indices and all of that. So this is the overall system structure of a database management system. Now, finally, we look at application architectures. We simply have architectures? Is it a two-tier? That means you just have, the front end and the back end, where the front end is the pretty part, what people see, the interfaces, the drop-down menus, and then the back end, of course, is your database system, where, the grinding engine of the work. Sometimes we have a three-tier system and there's a logic in between, the front end and the back end. So all of this can be done structurally, and then, you can build your applications over your databases. It's just a quick introduction into database management systems. There's so much, to learn in this, and we're trusting God that subsequently would have some hands-on and detailed description of all of these parts of the database